So the first problem we're going to look at is this investment problem. But this investment problem is based on a concept called knapsack problem. Okay. The knapsack problem goes like this. So you have a knapsack and you have a bunch of items that you want to pack into the knapsack to take it to a trip or something. Now the knapsack has a limited capacity. You cannot pack all of the items into the knapsack. Okay. So you can only pack what the volume of the knapsack allows. Now each item that is available for you to select has a particular value to you in terms of what use it is, the use value of these items. Now you want to select that combination of items to pack in the knapsack such that the total value you can derive with the use of those items is maximum. So this is the typical knapsack problem. So which item you're going to select, okay, and those are the 0, 1 variables, binary variable. If a variable associated with a particular item is equal to 1, then you're going to select that item. If it's 0, you're not going to select the item. Then the group of items that you've selected, then you add up all the values of that and you want that to be maximum. So that is the underlying principle which you will see in this problem. So we have 7 different investment opportunities, okay, and these are the cash required. Okay, so these are like the volume of each item that it'll take in the knapsack. Okay, it'll occupy. So these are the cash required. And each investment will give you a net present value. So this is your use value of the items. You cannot invest in all 7 because you have a limit on the cash available, which is only 15,000. So that's like the volume limitation of the knapsack. So within that $15,000, okay, you want to select a combination of these 7 investments such that the total net present value that you will derive from the selected investments is maximum. So that is the problem. So let's go to Excel and then see how to set it up. So here is the problem and here are the input data. So let's do some formatting. Okay, so investment cost and net present value, these are dollar amounts. So I'll change that to currency and we don't need the decimal places, and I'll color code that light blue. Okay. Now net present value per investment dollar, we won't use that, but we can find it. Okay, for each dollar that you invest, how much net present value you're going to receive. Okay. Now decision whether to invest, and here remember 1 is equal to invest, 0 is equal to don't invest. So you're going to have 1 variable for each investment opportunity. So those are our changing cells. So let's give names here. Okay, so the constraint here is only one constraint. That's the budget constraint. How much money we're going to invest, and that should be less than or equal to the budget. So there will be some product of the investment cost with whether it's going to be selected or not, and this should be less than or equal to the budget. Okay, now the total net present value is the sum product of net present value and the investments, whether a particular investment is going to be selected or not. Now, that is the objective that we need to maximize. So let me so let's give names here. Okay, now we are ready to run solver. Now we want to maximize net present value. Now changing cells are these. Okay. And the constraints are that is less than or equal to budget. That's one constraint. And we also need to make sure that these numbers are binary. So we have a binary constraint for the changing cells. So here is how you set the binary constraint. You select the changing cells, and from the center you need to select bin. That bin would make these cells binary, 0 or 1. If you don't put this constraint, then you may not, often you will not get 0 or 1. You will have like 0.7 or 0.3 or something like that. Okay. Now it's non-negative, and make this simplex LP. Okay, that's it. Now we solve. Well, one more thing we need to check. So go into options, make sure that this is unchecked, and let's make this 0. This is a small problem, so it's not, 0 will not make it any longer for solving the problem. Okay, so here is the solution. So the optimum investment plan is invest in 1, 2 and 5. Okay, so those are the 3 ones that we have, and you'll need $14,500. So you're within budget, and your total net present value is $46,000. That's the maximum possible value.